Hi there. Welcome back to Weather Analysis with Mr. CB. And we're going to be continuing on with the second part of this series of these videos. And in this video, we're mostly going to be talking about winter weather. Um, I'm also starting severe weather videos too, so you can check those out if you're interested. So the first thing that we're going to talk about are the challenges that exist with winter weather forecasting. The first one is precipitation type. So there's three types of winter precipitation that we're mostly going to be concerned with, which is snow, sleet, and freezing rain. Two of these are a lot less concerning than the other. I mean, any of the three can be problematic to an extent, but as you might know, freezing rain is going to be the most problematic because when that freezing rain is going to freeze onto the surfaces that it connect or that it falls on, and so uh, it's going to freeze on power lines, it's going to freeze on trees, causing limbs to break or trees to fall down. And it's going to also go on the roads, causing hazards on the roads. So that's why it's really important to know what type of precipitation that we're going to have. But as you'll see later in this video, there can be very subtle differences between which type we're going to have. And we still have relatively limited technology and um, abilities to decipher sometimes between subtle temperature differences. So minor errors can be very bad. So just a 1 degree Celsius difference in our environmental temperature line can change what type of precipitation we're going to have. And even though that sounds like a small number, that can still happen. Also, you can have other factors at play that add to the complexity of the situation. For example, if you have a upper level low, well, we know that a low has counterclockwise flow. And so it can bring up warm, moist air from the south. I say up, I should really say northward. Um, and so that can change also what we have going on. All right, the next thing we want to talk about is the snow to liquid ratio. So this is a ratio, of course, and it's how much snow is needed to melt into 1 inch of liquid water, I should say. So you might be confused about by this at first because you might just think, how could that be different? Like, if you melt the snow, wouldn't it just be the same? That's not correct, actually, because we can have different levels of moisture within the snow. And that's the reason why you can have soft snow or wet snow. And so we have this ratio to help us describe um, how much moisture we have in the snow. And what the number really means, though, is how many inches of snow. Really should have said that. How many inches of snow are needed to melt into 1 inch of liquid water? So you can see examples here, 6-to-1 ratio or 20-to-1 ratio. So if you want soft, fluffy snow, it's going to be a high snow to liquid ratio. And wet snow that's like more compactable is going to be a lower ratio. So, for example, that 6-to-1 ratio is going to be wetter snow than the 20-to-1 ratio. And another thing is the environmental temperature line is going to be further away from the freezing point for the higher ratios. All right, so we're going to talk about the three types of precipitation. First, snow. Of course, you probably know what snow is, but its technical definition is going to be white or translucent ice crystals that fall from the sky, essentially. But they're going to most easily form in our dendritic growth zone that's from 12 to 18 degrees Celsius. That's going to be where the ice crystals grow the best. The temperature line and the dew point line are going to be very close together in the upper atmosphere. And what does that mean? We're going to essentially, well, and it's going to be close to about or over 70% relative humidity. So we're going to have more moisture present. So it's going to need to have a lot. We know there's more moisture present if those two lines are close to each other, the temperature line and dew point line. Hopefully you remember that from the previous lectures. Um, but we will look at an example soon. Um, if all of the environmental temperature profile is below 0 degrees Celsius, we are almost certain that the precipitation will be snow. If some of it goes above freezing, then we'll have freezing rain or sleet, or sometimes, occasionally, it can still be snow, but we're not going to really talk about that. But what those two bullet points meant is, well, you'll see in the next slide. And I'm going to come back to this visibility, but we're going to look at this right now. So this is not actually what our skew T log P looks like because remember, for our skew T log P, our temperature lines are going to really be tilted, but this is just showing you instead a situation where it just goes straight up. Um, so this is our freezing line. So this is not like our environmental temperature. Obviously, this is just a mathematical statement that this is freezing. But this blue line is environmental temperature, and notice how all of it is to the left of the 0 degrees Celsius line. What that's going to tell us is that we are almost certain that the precipitation will be snow. So if we see models showing this, then that's going to tell us that we'll probably have snow in the future. So, and it's once again, it's because this blue line is all to the left of this line. As far as visibility goes, as defined by the uh, AMS, we can have differing amounts of visibility depending on if we have light, moderate, or heavy snow. Obviously, the more snow, the lower visibility. Light snow is going to be visibility of 1 kilometer or more, moderate in between 1/2 and 1 kilometer. Heavy snow is going to have visibility less than 1/2 kilometer. Now we'll talk about sleet. Um, Sleet is a type of precipitation um, where we have snowflakes that are partially melted and then they refreeze before reaching the ground. So they partially melt to where the outside of it is liquid, but that we still have the inner ice crystal that we had. But then it reaches another colder layer that causes it to refreeze again, and they're going to essentially be ice pellets. So they're going to look like little, almost like little hailstones as they reach the ground and they bounce. So that's why sleet is not as bad as freezing rain. A lot of people in the general public mix these up, but sleet is not actually going to be that problematic. Of course, it can be like as far as visibility goes, but it's really probably of these three, in my opinion, it's probably the least problematic. Because it's just going to bounce, just almost like little hailstones. Of course, for driving purposes, you still have to be careful, but it's not going to typically cause power outages. Um, and there is a liquid ratio that's involved with this as well, but it's very low, 2 to 1 or 3 to 1. And once again, the reason why that it melts in the first place is that it reaches an elevated melting layer, also called our warm nose. And this is the layer where the environmental temperature is above freezing. So whereas for this graph, all of the line is to the left of the 0, this time we're going to have part of it that goes to the right of it. So just imagine it's going down. We have snow, as you can see, But oh no. Well, not really oh no, but you know what I mean. It goes here and then it partially melts, but like I said, it still has the inner ice crystals. Then it falls as sleet. Ends up falling as sleet because it gets to a deep cold layer where it has enough time to refreeze and it hits the ground as ice pellets. Um, yeah, that's all I need to say for that. Um, now, snowfall totals. Well, this, I don't know why I didn't put this with the snow part, but if you have 2 inches of precipitation falling from the sky, you actually, that doesn't mean you're going to have 2 inches of snow. um, you multiply it by the liquid ratio to know, and that we kind of already defined that before. But if you have a 6-to-1 ratio, then that means there's going to be expected 12 inches of snow. If you have a 12-to-1, then 24 inches because you multiply it by the 2 inches of precipitation that you get. Since sleet has a very low ratio, which is like 2 or 3-to-1, the ground totals will be much lower if precipitation transitions into sleet. Um, Freezing rain is the most important type of precipitation, winter precipitation, in my opinion, because it's the most problematic. So it's rain that falls in liquid form. So as you're looking at it falling from the sky, it looks like liquid. It looks like rain. Unlike sleet. Sleet, when you see it falling, it looks like ice. But freezing rain looks like rain when you're looking at it falling, but it freezes upon impact. So anything that it hits, it freezes onto. Um, so if it hits power lines, it's going to freeze onto that. Hits trees, it's going to freeze onto that. You'll just have ice surrounding the trees. And hits the road, it's going to freeze to the road and cause icy roads that are really dangerous. And when it freezes onto the trees, if it gets heavy enough, it'll break the branches off the tree that can fall on power lines, and then we have major power outages. So that's why freezing rain is very important. But as you'll see, um, these statements down here, I'm just going to say as we're looking at this, because I think that will just be better for me to do. So this graph looks pretty similar to the sleet one. But what's the difference? Here it says shallow warm layer, so the elevated melting layer is small, and then the cold layer below is big. This time, the elevated melting layer is larger, and we have a small cold layer below. How does that change things? Well, that means that it's going to melt all the way into liquid form. So it melts it's snow, and then it's such a big warm layer that it melts all the way into liquid, and then it doesn't have enough time to refreeze once it gets into this cold layer. So it still is rain and it's still liquid until it hits this, because the ground is freezing, and since the ground is freezing, it will freeze to it immediately. Or not necessarily ground, whatever surface it touches first. So the difference is this warm nose that we have here, this red, it's over here longer. It's over here further and it's over here longer. And so that is a very subtle difference right here. The only difference is that this red part is further out. And so this is going to be freezing rain. And so these are the reasons why these types of precipitation can be difficult to decipher between. And if we just have a calculation error or the models are off, we might incorrectly define what precipitation that we're going to have. And that is why typically when we are forecasting um, situations like those where we know there will be an elevated melting layer, we do not say in the forecast that there's going to be sleet or freezing rain. We might say wintry mix. That's why we say wintry mix, because the forecasters don't want to confuse the public or say something incorrectly. So they'll just say wintry mix because it's a very subtle difference between if it will be freezing rain or sleet. But obviously, whichever happens is going to be more problematic than the other. That's why it's important to prepare for freezing rain. it if you see wintry mix, expect that you could have a power outage. And in my case right now, in fact, it's kind of coincidental, but there's a winter storm warning where I am, and the exact thing is going to happen in the next couple days where I'm not entirely sure. We don't know if it's going to be freezing rain or sleet, but we're hoping there'll be sleet. And maybe I'll post a video for that, like as it's happening. But that's all I have to say for this video. Thank you for watching.